Hi there, so we're going to do a little bit of curve sketching with this question. So first of all, it says on the same axis sketch the graphs of the curves with these equations, and our first equation there, y equals x squared brackets x minus 2 and y equals x brackets x minus 6. So the first thing we're going to do is we're going to multiply them out. So we'll start with the first one. So y equals x squared times x minus 2, which means that y equals x cubed minus 2x squared. So that means we've got a positive cubic there, which looks that sort of shape. Now let's just consider our intercepts. First of all, when x equals 0, y equals 0. So that's somewhere to plot. And they've given us the equation in factorised form. So we can look at that and you can see actually that the 0 is a repeated root, and there's another root when x equals 2, y equals 0. So that's another point there. And that's pretty much all we can get out of that one, just to note that this is a repeated root. Now for the other one, y equals x brackets 6 minus x. Let's multiply out and we get y equals 6x minus x squared. And that tells us that it's a negative quadratic, like that. And similarly, when x equals 0, y equals 0. And the factorised form tells us that when x equals 6, y equals 0. So we've got some points for this one too. There we are. So to me that looks like we've got everything we need to plot the thing now. So let's go and sketch it even. So there we are, and it's got to go up to 6, hasn't it? So 1, 2, 3, 4, 5, 6. Let's bring it back down here as well a bit. Okay, so let's deal with the first one. So let's do it in different colours. Let's have the first one in red. So this goes through 0, 0, and that's the repeated root, and it also goes through 2, 0, which is just there. So that's number 2. So the graph comes down out of the sky here, repeated root there, and off we go down there. Okay, not particularly pretty. And we'll do the second one. This is our negative quadratic. So it goes, comes up out of here, through there, and back down through 6, which I believe is just there. So that's 6. Okay, that's beautiful, isn't it? It's probably worth putting our coordinates on there. 0, 0. And that'll do there. I'm sure you can do a better job than me. A bit of paper. So now we are going to use algebra to find the coordinates of the points where the graphs intersect. So this is a trivial bit of algebra. You'll notice both equations equal y, so we can just set them equal to each other, and I'm using the multiplied out form, so that's the first one that comes from up here, and then I'm setting that equal to the second one, which was 6x minus x squared, and that one is coming from just here, and we'll go from there. Should be nice and straightforward. So we've got x cubed minus 2x squared plus x squared minus 6x equals 0. It should be an x, shouldn't it? And we'll simplify that up a bit. X cubed, and then we've got minus x squared minus 6x equals 0. Now we take x out of it, common factor here. X squared minus x minus 6 equals 0. And obviously we can factorise this, or I say obviously, hopefully we can factorise it. So there's the x, and put the x there, and it's going to be 3 minus 3 and plus 2. And then we can see our three solutions. So first of all, x equals 0, because if this was 0 it would make the whole lot 0. And then we've got x could be 3, pardon me, that's this one here. And then finally we've got x could be negative 2. And it says it wants the coordinates, which means we need the y coordinates as well. So I'm just going to use the simpler of the two equations. I'm going to use the y equals x times 6 minus x. So let's do that. So y equals 0 times 6 minus 0. So that's 0. So that's our first one. No surprises there. And then we've got y is equal to 3 times 6 take 3, which is going to give us 9. So then we've got 3, 9, there we are. And then y is equal to minus 2 times 6 minus 2, which, have I done that right? Let's just check that. Yes, it is, isn't it? So that gives us minus 2, and that's times 8, so that's minus 16. So we've got minus 2, comma, minus 16. And now we're going to go on to call 2. So let's just get rid of some of these. It's a deep mystery to me why these appear. I shall have to Google it in a minute. Now, use the factor theorem to show that x plus 2 is a factor of f of x. So that's very straightforward. We are just going to substitute the number minus 2 in. So f of negative 2, and if it's a factor it should turn out to be 0. So let's give that a go. So we've got minus 2 cubed plus 4 times minus 2 squared plus minus 2 minus 6, which gives us minus 8 there, and that works out to be plus 16, and then minus 2 and minus 6, and that works out to be 0. Therefore x plus 2 is a factor, and that's the factor theorem. Now, to factorise f of x completely, we are going to divide f of x by x plus 2 and see what is left over. So we have x plus 2 there, and we are going to divide x cubed plus 4x squared plus x minus 6 by it. So off we go. X's into x cubed go x squared. And then we multiply this by each of these two things. So x squared times x is x cubed. And then x squared times 2 is plus 2x squared. And we subtract. Of course, these two will cancel, and then we have 2x squared left over here. And we bring down the next bit. And then we do it again. We take the x here and we say x is into 2x squared go 2x. So we put 2x there. And we take the 2x and we multiply it by that to get ourselves 2x squared. And then we multiply 2x by 2 to get positive 4x. Then we subtract. So there we've got nothing here and minus 3x here. And we bring down the minus 6 at this point. And then we divide it by x. X is going to minus 3x minus 3 times. Take the minus 3, multiply it by the x to get minus 3x. Minus 3 times positive 2 is minus 6. And we have a result of 0. And that's what we're expecting because we know that this is a factor. So this is our other bit. So we can write f of x as equal to x plus 2 times x squared plus 2x minus 3. And now we can factorise that quadratic. So x plus 2, and it should factorise fairly nicely. It's going to be 1 and 3, isn't it? So it's going to be minus 1 and plus 3. And that there is our solution. And now we get an extra mark for writing down all the solutions to this equation when it equals 0. Now that's really important because this whole pulling the numbers out of the brackets only works if it's 0. So our three solutions are x could equal negative 2, or x could equal 1, or x could equal negative 3. And that's it. And I've got a whole bunch of random stuff there. So I hope you found that useful. If you've got time, maybe go and find yourself another question of this type. This was one that wasn't done well in the mock, and I'll speak to you soon.